Today's lesson will teach me to multiply binomials. This is day 2 of multiplying binomials, and it will also teach me how to multiply binomials and trinomials. Alright, this starts out with you try. Multiply. Write your answer in standard form. Please pause the video and try the 4 following problems. You paused it, right? You're replaying it now? Alright, here are my answers. For letter E, I used double distribution. I did the first 2, the outer 2, the inner 2, and the last 2. Notice I had 2 like terms in the center. A -6, -7 gave me a -13x. For letter F, I chose to use the Punnett square method. I put one of them on the top. If you want, you can add a +3. Notice the minus going with the 9. When I brought the 2 times the 4, I got 8. Notice here, though, that I had a single x and the x squared, giving me x to the 3rd. Oops, I see an error. That's a 6. You know where am I at? There we are. -9 and 4 give me the -36x squared. A -9 and a +3 is a -27. Here, nothing ended up combining. So it stayed a polynomial with 4 terms. All right, the next 2. The next 2 were kind of the special cases, just like C and D above. For letter G, when I chose to use double distribution, 1, 2, 3, 4 terms, it just so happened that those 2 center terms canceled, and it's because one had a negative and one had a positive is the only differences in the 2 binomials. So 4x squared minus 49. For letter H, it was discussed in the previous video that this squared cannot be distributed and put through. It means that there are 2 binomials, one of which is 5x minus 1, the other of which is also 5x minus 1. So when I went through and multiplied 25x squared, -5x, -5x, -1 times -1 is a +1. So when I combined my like terms, -5 minus 5 is a -10. The following problems are a little bit more tricky, same concept, but here, if you notice, you're taking a binomial, 1, 2 terms, by a trinomial, 1, 2, 3 terms. In letter B, we're actually taking a trinomial times a trinomial. This can be done in 2 different methods. We can use double, or think of it even as triple distribution, or a larger Punnett square. All right, so if we're going to multiply, I'm going to show you using both methods. To start out with that idea of double distribution, we're taking 6n to everything inside. I know a lot of you have a tendency of drawing all these little swoopy things. Actually draw them as you do the multiplication so you can make sure you don't skip anything. 6n times 2n squared, 6n times n, 6n times -7. I'm going to switch colors. Next thing, careful with the -8. I'm going to stack my like terms because otherwise I'm going to have a problem that takes up a ton of space. I'm going to go right below. -8 times 2n squared is going to give me a -16n squared. Notice I put it right under the other squared term. -8 times n is a -8n. -8 times -7 is a +56. Now you very easily could have put all of these terms way out here, but then you're looking at a lot of left to right. Students organizationally have a much better time when they're looking up and down. Think about combining like terms. 12n to the 3rd, a +6 minus 16, a -42 minus 8, and a +56. If you like the Punnett square method, I'd put your binomial on the side and your trinomial up top. the values you get will be exactly the same. 12n to the third, 6n squared, minus 42n. You'll get your negative 16n squared, negative 8n, and a positive 56. Here, when you go to combine like terms, you're looking on the diagonal. So we have 12n to the third. When I combine those like terms, there's my minus 10n squared. Combine the ones highlighted in green, there's your minus 50 and your positive 56 as well. When it comes to a problem like letter B, again, it's double, triple, however many distributions you want. This x squared needs to get to everything. This positive 2x needs to get to everything. And this minus 4 also needs to go to everything. There's a ton of stuff. If you think about stacking like I did in problem A, you'll have one more line of work where you can kind of match things up. For problems this large, the Punnett squared method is going to be your best bet organizationally. So I'm going to have my x squared, my positive 2x, and my minus 4 down the side. I'll have this 2x squared minus 3x and a positive 5 along the top. All right, say it to yourself as you multiply. A 1x squared times a 2x squared. 1 times 2 is 2, but I have 4 x's there. I'm going to put my finger, and you can't see me, you can only hear me and see my pen, but if I take this term times that term, and I very often use my finger and kind of drag them in, if you can kind of get a visual, that way I can keep track of where I'm at. So if I take 1x squared times negative 3x, well 1 times negative 3, I have 2 x's here and 1 x up here. 1x squared times 5 is 5x squared. All right, I'm down here with the 2x. 2x times 2x squared is 4x. 1, 2, 3. 2x times negative 3x is negative 6x. Notice 1 there, 1 there. There's 2. 2x plus 5, 2x times 5 is 10x. Last one, negative 4. Negative 4 times that 2x to the second power. Negative 4 times the negative 3x up top. Negative and negative is a positive. Negative 4 times a positive 5 is a 20. Step back, admire your work for a second, and also notice where your like terms are. Our like terms in this Punnett square should be on the diagonal. Oops, sorry about that. Because of the 1 and because of the 2 over there, there should be the 3. So they should be on the diagonal, should be on the diagonal. So when I go to combine like terms, nothing combines with my 2x to the 4th. Look at what's highlighted in yellow. 4 of these things and a minus 3 of these things. Look at what's highlighted in green. If I take negative 8 and negative 6, it's negative 14. A negative 14 combined with a positive 5. I have like terms that didn't get highlighted here. 12 plus 10, I'll my pen back, is going to be a positive 22, and then that plus 20. To be most correct, don't need the 1. When it says multiply and write your answers in standard form, notice your exponents go from 4, 3, 2, 1, none. Whoops. 20, not 2. All right, one more problem. All right, in this problem, it says find the area of the shaded region. Well, what is area? Area is the square units within a shape. The two shapes we have here are rectangles. So we find the area of a rectangle by doing length times width. In this particular case, our length and our width are numbers, but they're monomials and binomials. If I want to find the area of the shaded region, then I need to take the area of the great big one, and I need to subtract away the area of the small one. Find your answer for the big, take out your answer for the small. So you're going to have some multiplying here, and you're going to have some subtraction. So the area of the big one, length times width. So it's 6x plus 2 times 5x plus 8. But you want that whole thing. Your whole answer is going to be subtracted. Area of the small, length times width, 5x times x plus 6. But again, I'm going to wrap this up, and I know it looks crazy with all these parentheses, but I want all of the big subtracted from all of the small. All right, I'm going to start double distributing. That's going to give me 30x squared. It's going to give me 6 times 8 is 48. There's a 10x, and there's a 16. So when I combine like terms, I have 58x plus 16. That, remember, I'm keeping all of it together, all of it together. That whole answer is the area of the big. Now let's do the small one. For the small one, we'll distribute. 5x times x is 5x squared. 5x times 6 is a positive 30x. So that whole answer wrapped up is the area of the small. And I'm just going to move it down because there's no like terms to combine like there was in the other one. So these two things need to be subtracted. For some visual aid, I'm going to highlight. I have a squared term here and a squared term here. Those will be subtracted. I have an x term here and an x term here. Those will be subtracted. And then the 16 doesn't go with anything. All right, so now let's subtract. I'm going to take what's highlighted in yellow and subtract. So 30 minus 5 is a 25x squared. The greens, subtract. 58 minus 30 is a positive 28x. And then that 16 minus nothing is just 16. Word to the wise, if you don't use parentheses here, it gets really confusing because without the parentheses, this is what it looks like. It looks like you're only subtracting those values, that you're not subtracting that too. So you really do need to keep all of your big separate from all of your small. For your homework, use whichever method you prefer. I don't recall what the homework assignment is tonight, but if it specifies one versus the other, honestly, use whatever method you prefer. When it comes down to the quiz, the direction will be multiply. I don't care whether you use FOIL, double distribution, Punnett square, area model, whatever you want to call it, multiply correctly, and you'll get the right answer. Thank you so much. Let me know if you have any questions.